All right, Emma, you ready to do this? You can give me a thumbs up. Okay, cool. All right, we're gonna get started. So first, I'd like to welcome you to Mueller Field Station. I'm actually in our classroom right now at the field station. And this is our first virtual Speaking of Nature events. We usually have them here at the field station upstairs, but the circumstances won't let us do that. So all good. My name is Ali Esposito, and I am the Conservation Education Outreach Coordinator here. And for those of you who are unfamiliar with Mueller Field Station, we are part of Finger Lakes Community College. And Mueller Field Station is located in the southern Honeyway Valley. It's a beautiful space. So we host many different environmental education programs. We have K through 12 students come down. We have Finger Lakes Community College students take conservation courses down here, and then we have community events. So I'm looking at the number of attendees, and we would never be able to host this many people. We don't have much room at the field station. I've been waiting to say that all day. I hope you're laughing at home. So just a few things before I introduce Emma. We have our next Speaking of Nature event scheduled for October 22nd, and the topic is bats. So kind of get us into that Halloween spirit, talking about bats, and that will be October 22nd at 7 p.m. And you can look for updates on our Facebook page, on Instagram, and those will be up shortly. So without further ado, Emma Gutierrez and her dog are here to present today. Emma is a SUNY Environmental Science and Forestry graduate, and she is a mycologist at Hawk Meadow Farms. I had the privilege of going there this summer to camp. You can actually camp at this amazing place. And Emma led me on a tour of the shiitake mushroom farm, and it was amazing. She has a love and knowledge for these mysterious organisms, and it was just a contagious, feeling that I got from it. And I had to have her present for one of our series events. So I'm going to stop talking and hand it over to Emma to start her presentation. Enjoy, everybody.
All right. Hello, everyone. Welcome. Thank you so much, Ali and the field station, for having me. It's kind of sad that I can't see everyone in person because I like being able to see all you guys, but it's kind of cool in the way that, like Ali said, we get to branch out and get a lot more people that we normally wouldn't be able to fit in there. So that's kind of exciting. This is super cool. I've seen over the past couple years this giant boom of interest in mycology. That's been super exciting. And so I'm happy to have all you guys here ready to learn, excited to learn more about mushrooms, whether you know a little bit about mushrooms or nothing at all, or maybe you have tried to go out foraging or you know a lot. I'm hoping that there'll be a little something for everyone. So I'm going to pull up the presentation. Okay. So I hope everyone can see me or see the presentation. All right, let's get started. Fantastic fungi and how to farm them. So here's just a little sneak peek about what we're going to talk about over this next 45 minutes, maybe an hour. I'll do a quick introduction about myself and the farm and mycology 101 for people who don't know anything about mushrooms. And then we'll talk a little bit about what it takes to actually grow these mushrooms and the process on the farm. And then finally, we'll talk about super fascinating topic, mushrooms as medicine at the end. So just a little bit about me. Like Ali said, I graduated from SUNY College of Environmental Science and Forestry. I studied conservation biology there, traditional ecological knowledge with focus in mycology. And since then, I've become a wild food forager. I've worked in a couple different research labs and institutions in mycology, and now I have landed at Hawk Meadow Farms as their mycologist, and I'm very thankful for that. So Hawk Meadow Farms, for those of you guys don't know, it was founded back in the 80s by Steve and Ann. They are lovely, amazing people. They are so connected and tied to their land. It's really, really been inspiring to be able to watch them work and all the amazing things that they do. So our farm is definitely very unique, different from a lot of other farms. Our main focus is making sure that we give back to the land, that everything that we're doing is not just to make a profit, but we're also doing things that's going to be good for the ecosystem around us. And that is extremely easy to see if you guys were to ever come and visit us. There's the diversity of plants and animals, so many different birds and insects on this land. It's a truly thriving environment. And it very much pays off for the land. And because we like to work with the land, we have a lot of diverse offerings, not just which people know us for. Things like maple syrup, we do chestnuts, we sell black locust posts, which this tree right here is a black locust. That's kind of like a unique thing in that it's a highly prized wood for builders because the wood is rot resistant. And so you don't have to treat it with anything, and it'll last for hundreds of years. And so a lot of people use it for park benches or siding, a lot of really cool things. And another big part, like Ali said, of our outlook is doing a lot of ecotourism. So we really want people to come out on this land and kind of have an experience, see this beautiful landscape, how it can be thriving for the land, and also we can get some stuff out of it. When it's not COVID happening, we do a lot of classes and workshops every year. We have campsites through Hip Camp that people can book and come out and stay on the land. And we're always doing tours, so we always encourage people to come check us out and see for yourselves how beautiful it is. And just a cool side note on a big project that's happening right now, the mushroom side of things has been exploding. Tons of people interested in it, and we can't even keep up with the demand anymore. And so we're putting up this brand new building where a lot of our mushroom processing and drying and making our tinctures and medicines will happen out of this new building. But it's really unique in that the entire building is almost completely compostable, and we're kind of using our same values and looking out for nature when we built this building. And so all these stones that you guys see at the bottom here, those are all recycled from an old barn that came down on the property. All of the wood came locally, was milled locally, and it's actually insulated by straw bales. And right now we're actually working on plastering the outside with clay that we got on the land. And so this building is actually capable of lasting about 100 years, but it's different from other buildings in that at the end of its lifespan, you could just knock down the building and put it back into the earth. You're not going to have all this waste material. So that's been a really cool project happening right now. But let's get into why everyone is here. Let's talk about fungi. So I get a lot of people who come for tours onto the property, looking at our mushrooms, and they think that fungi are plants. And that is a very common misconception. Historically, fungi were actually put into the kingdom of plants up until the 1960s, which is crazy that it took so long because fungi are extremely different from plants, extremely different from almost every other organism on Earth. And just the importance that they hold within our ecosystems is just amazing. So it's crazy it took so long for people to realize that they are actually their own kingdom, completely separate. There's about 120,000 species that have names right now, but we think that's only about 5 to 10% of the actual true diversity in the fungi kingdom, because fungi can range anywhere from microscopic yeast that we use to make our breads and alcohol, all the way up to a vast amount of different mushrooms that you guys would see out on hikes. And just to kind of put into perspective how crazy the diversity is. So back in college, I worked in a lab that was trying to describe a couple new species of fungi that were microscopic, living on insects that lived in bird feathers. So if you think about how specific that is, and then extrapolate that to the entire world, there's a lot of fungi out there. And fungi are very different from plants, like I said. They're heterotrophs, which is what we are. So they can't photosynthesize like plants can to produce their own food and nutrients. They have to eat food, ingest their own food. But unlike us, where we have our stomachs to do all of the digestion, they do what's called external digestion. So they'll kind of secrete some enzymes onto whatever they're trying to eat and break down, and then kind of move into it once it's broken down and take that up inside their bodies. And so that kind of breaks them down into three major groups based on how they're going to acquire these nutrients, which we'll talk about in a second. So when you guys see a mushroom, it's actually not the organism itself. The mushroom is the fruiting body, is what we call it. So it's a similar idea as if you were to have an apple tree that produced apples. The purpose of the apple is to help the tree reproduce, but it's not the organism itself. It's the same idea. Mushrooms' only purpose in life is to help the actual organism, the fungal organism, help reproduce. And they reproduce through spores. And so when you guys look at a mushroom, it has the big cap that everyone is used to seeing, and underneath are these gills, and within those gills are millions and millions and millions of microscopic spores that the mushroom will release into the earth to use usually wind dispersal. They'll float around until they land on a good spot. Other mushrooms will have, instead of gills, they'll have these tubes underneath that look like a bunch of dots. Some might even have teeth, all based on how the mushroom is going to disperse those spores. And all mushrooms are made out of chitin, which is the same material that insect exoskeletons are made out of. So that's why it's so hard for our bodies to digest it. That's why it's really important that you cook mushrooms. And they need moisture to grow, which is why they say it takes about 3 days after a rain to start seeing mushrooms. If you're ever interested in seeing the diversity out there, go after a rainstorm. And these are just some pictures to kind of show you guys that just vast amount of diversity, even just within the fruiting bodies, within the mushrooms themselves. So this guy right here, some of you might be familiar with. This is a very common edible mushroom that people will forage for. It's called chicken of the woods. When mushrooms grow like this, they're known as polypores. This guy right here looks super weird. It's known as an earth star. It'll actually disperse the spores through rain. So when a raindrop falls on this kind of big bulbous part here, it'll release its spores that way. But you guys can just kind of see this is just like a very small sampling of the amount of diversity that's out there. So, like I said, mushrooms are only there to help the organism reproduce. And what the whole body of the fungus is called is known as mycelium. So mycelium is an extremely fascinating, really amazing organism. It's the reason that got me into mycology in the first place. They're kind of this fibrous net-like material, kind of look like a spider webbing. They're microscopic. They live under the soil. So for a long time, we called the fungal community the hidden kingdom, because most of the organisms you'll never see. You're only seeing their fruiting bodies come up. And so what they'll do is they'll move in the soil, but not like how we understand moving, like with mobility. They'll move in that they'll just grow from the tips out in the direction they want to move. And they could go over 1/2 mile a day, which is crazy. And some scientists even think that that means that the mycelium is immortal, because it'll move in a direction and it'll just keep growing and keep building on that mycelium, but then just kind of leave the part that it doesn't want just behind, just to decompose back into the soil. And the largest organism that we know of is actually a fungus because of this. It's known as a honey fungus. It's in Oregon, and it's over 3 square miles large, and we think it's over 8,000 years old, which is crazy. And these organisms are extremely vital in our ecosystems, and we really have only been able to understand a lot of their ecology and biology really in the last 50 years is when we've had this understanding, which is ridiculous because the work that fungi do in ecosystems make the world livable for not just so many other organisms and plants, but for humans too, which we will explore right now. So like I said, there's 3 major groups of kind of lifestyles, you could think of it as, that these fungi will grow, all based on how they're going to get that energy to survive. And they're not all going to be good, positive as we see them. Whoops. The first group is parasitic fungi. This is where a lot of our negative connotations of fungi come from, because these fungi get all of their energy from things that are still alive. So these are a lot of our plant pathogens. So if you think of like mildews and rusts and wilts that you would see on plants, like this picture right here, this is actually the chestnut blight, which is a fungus that's responsible for killing off almost an entire tree species in the US. And a lot of our human diseases are also these parasitic fungi. So if you think like athlete's foot or like yeast infections. And this picture right here is a really, really crazy one, like something out of a sci-fi film. This is known as cordyceps. And so what this fungus will do is that its spores will travel through the air and it'll land on an insect, oftentimes an ant. And the ant will ingest those spores and the mycelium will grow and it'll almost brainwash the ant to want to climb as high as it can on a piece of grass or plant. And once it's really, really high up, the fruiting body will just take itself out of the insect like this, and it'll release its spores from a really high place. There's also some fungi that are active predators, which is really weird to think about, that they'll have on their mycelium little like lassos. So when little microscopic insects or like worms and things will go through, it'll actually like kind of wrangle them up and take them in and digest it, which is really scary. But another group is known as mycorrhizal fungi, and they are extremely amazing individuals. These are going to be the mushrooms that you would see popping straight out of the ground if you're on a hike in the woods. But they get their energy, their nutrients through mutualistic relationships. So it means they'll give and take things with another organism. And 90% of plants have some form of relationship with these type of fungi. And so if you see in this picture here, so here's that fruiting body, those mushrooms, and underneath is all their mycelium with the plant roots. And the mycelium will actually go up to a plant root, connect itself to the outside, and the plants will photosynthesize, create those sugars that it needs, but it'll create a little extra and give some to the mushrooms, to that mycelium. And in the return, the mycelium will go out into the soil, and it'll pick up different kinds of nutrients, things like phosphorus, water, even some kinds of protections, and give that back to the plants. And so I like to tell people, like, think of it that it's like why it's so difficult to grow plants inside is because they're lacking this relationship, which is extremely fascinating. There even is some belief that fungi evolved way before plants did on land. And we think that that's even the reason why plants were able to colonize on land, is because they had the help of fungi billions of years ago. Another really cool thing that they do is, for years and years, scientists were perplexed because they would watch a tree within a woodland, within a forest, that would get sick from some kind of pathogen, some kind of disease that was out in nature. And other trees or plants within its vicinity around it would start producing different kind of chemicals to protect themselves from that disease. But for a long time, scientists didn't understand how these other trees knew that there was this pathogen around. And it wasn't until relatively recently where they realized that it was because of these mycelial networks, because of this mycelium underneath the soil, actually connecting plant roots to other plant roots. And the tree can send hormonal messages through those roots, through that mycelium, to kind of warn other trees around it. So there are the things that are connecting almost every living plant that you see. And they're the reason why there's such a vast diversity in plant life today, is because they're able to grow with the help of this mycelium. Whoops. So you can kind of see that depicted in this picture here. This is just grass, but this picture right on the left is a lot more lush, a lot more healthy looking, because it has this mycorrhizal fungi helping it. As opposed to this picture on the right, it's not as nice because it has to struggle a lot more to get these nutrients that normally the mycorrhizal fungi would help it with. So they're extremely important in ecosystems and that networking, which is why some people refer to it as the wood wide web, so the World Wide Web. A lot of people back in the day actually got a lot of ideas for the internet through looking at these organisms. And the last kind of lifestyle for fungus are known as saprobic fungi. And this is the group of fungi that we focus on when growing mushrooms on the farm. They're also extremely important ecosystems because they decompose organic material. So these would be all the foods that you would see, or the molds that you would see on foods if you were leave some bread out for too long. But they're also just so important in the greater ecosystems because if anything were to die, we call them nature's alchemists. They can take all of those nutrients that are tied up in those cells of whatever has died, whether it's a plant life or an animal, whatever it is, and they can break that down back into usable organic substances that can go back to the soil for other organisms to use. So they're extremely important in helping every living thing survive and cycling those nutrients around. They're also one of the only things that could break down lignin in wood, which is kind of the structural component of wood. So without them on Earth, we would literally be standing on, thousands and thousands of years worth of wood that can't be broken down by anything else. So they're so important. So that brings us to our next topic, which is how do you grow these mushrooms? Because they're not plants, they're a lot more, they're a lot older than plants, they're a lot more complex than plants, and so it's not as simple as just putting a seed in the ground and then, oh, we get a mushroom. They kind of have a mind of their own, and we kind of have to work around that to figure out what they like to get them to produce those fruiting bodies. And so because of that, this process is going to change based on the species that we're looking for to grow. There are a lot of species that we still don't know how to grow at all, even though lots of people have been trying for many, many years on all different farms and labs. We just can't crack the code for them. Some of these would be like truffles, these guys right here, or this right here is a morel. They're highly prized in the culinary world, but they're very, very expensive. And that's because we don't know how to grow them. Anyone that you would see to eat that would be on your plate, someone had to go out and wild forage that themselves. And a lot of mushrooms are only successful when they're grown indoors, which we'll talk a little bit more about that practice in a little bit. But for the most part, like I said, a lot of this knowledge is relatively recent. It's relatively new. So we're still trying to figure it out day by day how to make a lot of these species happy and want to grow for us. So what we grow a lot of, and what we'll talk about with this is how we grow shiitake mushrooms. And the reason why I picked this one to talk about is because unlike these other mushrooms, we're kind of starting at a blank slate on how to grow them. Shiitake are one of the rare ones where they've actually been grown for about 2,000 years in Japanese culture using this woodlot growing technique. And so we have all of this knowledge, all of this reference to look back on and learn how to grow them using these methods that have been used for a long time. Whoops. And so what we'll do is we'll take these pieces of wood. All of the wood that we get for inoculating comes from natural woodlot management practices. And so we're never going to go in and take down a piece of wood, take down a tree just because we need it for inoculating. We're only going to take things down that are either old or maybe a beaver got to them, or maybe they're looking diseased, so they're going to need to come down anyway. So we'll take these pieces of wood. We take what we call grains or plugs or spawn. And so that's going to be that mycelium that we talked about, kind of mixed with usually sawdust. And we'll put this wood up. We'll drill these holes into it using a special tool. That mycelium mixed with that sawdust will get put into those holes, and then we'll cover it up with wax. And we're going to cover it up with wax because they like that moisture in order to survive, to have them be happy. And once they're inoculated, they'll come out into these lawns here. We'll put them in what we call crib stacking. And so for shiitake, they're kind of more generalist mushrooms. There's some mushrooms that will only grow on one specific substrate or just a couple things. But shiitake are a little bit more general. And so the word shiitake in Japanese comes from shi, referring to shi trees in Japan. Take means mushroom. The shi trees in Japan are kind of related to our oaks, beech, hickory, maple trees. And so kind of within that group, we'll be able to take mushrooms or take trees to use. And there are some people that say that they'll actually pick up qualities from whatever tree they're growing on. So people like Steve, my boss, who's been doing this for so long, they're able to kind of almost like taste a shiitake and know what kind of tree it grew on because it kind of picked up some properties, which is kind of cool. So these logs will come out here with that mushroom spawn in it. They'll sit for about a year, and within that year, that mycelium will kind of move about the log, kind of get its bearings, kind of decide whether it likes it there or not. And then within that following season, after a year of kind of laying in wait, they'll start to produce their mushrooms. And so this picture is really cool, just to kind of visualize what's happening. This white that you guys see, that's the mycelium. It kind of makes these little bulbous shapes because that's each hole. And that mycelium is coming in and it's breaking down the sapwood in the tree. So when the tree was alive, that would be the area where all of that nutrients and water would be moving about the tree. And so you could kind of see that like ring here. And so like I said, that mycelium, its whole purpose is to break down the wood, is to break down those nutrients that's kind of holed up in the wood. So it's really cool to kind of see, this is, we're kind of taking a natural process of decomposing something and we're kind of subverting it, and instead we're getting something that's edible out of it, which is really, really cool when you think about it. So when they're grown in Japan, they'll have yards with millions and millions of logs that are inoculated, all stacked up like how I showed you in that picture. But in Japan, they have a much different climate than we do here in upstate New York. It's a lot more humid. It's a lot wetter in the air. It's a little bit warmer. We don't really have the luxury of having that high humidity, which mushrooms like to grow. So instead, we need to figure out our own ways to ensure that we're going to get mushrooms to grow, because we have schedules with restaurants and with markets. They need these mushrooms. And so we'll use the river to our advantage. This process is known as shocking or forcing the logs. And so we'll walk down with the stacks of logs. They'll get put into the river like this. They'll soak there overnight, and we'll come stack them on these A-frames, this right here. And within 9 days, we'll have mushrooms that are ready to eat, which is crazy. It happens very, very fast. And that's just kind of our way of knowing that, we know exactly how many pounds we're going to have every week to give to the people who have interest in buying them. And every single log, when it's in its peak, will produce about 1 pound of mushrooms. And every log will last between 4 or 5 growing seasons. And so after that 5 years, they'll still produce mushrooms, but it just won't be as much because those nutrients are breaking down. And so, of course, our last step there is harvesting. And so they'll show, little pins is what we call them, which we'll kind of see that first head of the mushroom popping out. And that produces tons and tons of force for those mushrooms to kind of push themselves through that log in order to come out. And that happens when there's enough moisture in the air and when the temperature is right, so between 55 and 85 degrees. And so, like I said, the whole purpose of the mushroom is to help the mycelium reproduce. And so its only purpose in life is to drop its spores. So once it's dropped its spores, it's kind of done with its life purpose, and the mycelium is going to stop putting energy into those mushrooms. And so the quality of the mushrooms goes down really, really fast. So we want to make sure that we're kind of picking those mushrooms before those spores drop. And so the way that we'll know is we'll feel underneath. You'll see those classic gills underneath, but they're actually covered up by like a papery material before they're completely opened. And so we want to feel underneath that we still feel that papery material and the gills starting to come out so that we know that those spores haven't been dropped. This is just another way that we'll grow some mushrooms. It's known as totem growing. It's a very similar concept in that we'll have our whatever wood that we decided to use. It'll be cut into thirds, and in between it we'll kind of like smush mycelium and that sawdust in between, so it's kind of like a mushroom sandwich. And we'll wrap them up, keep them moist. It kind of looks kind of silly for a year, with these bags around them, and then they'll start producing. And so that's just the way that some mushrooms prefer to grow, as we've been figuring out. So we'll grow our oyster mushrooms this way, we'll grow our turkey tail this way, and our lion's mane this way. They just seem to like it that way a little bit more. But there is a catch, of course. This is a very unique way to be growing mushrooms in the US. Probably about 95% of mushrooms are not grown this way. So this is very obscure. Most mushrooms in the US are grown using indoor methods. And so these are some pictures at an oyster mushroom farm that I worked at for some time using these indoor methods. And so it's very similar concept in that you have bags that are filled with that same substrate and that mycelium, but instead you can kind of perfect all of the temperature, the amount of water they're getting, the humidity, all of the nutrients, so that you get mushrooms that are growing super beautifully, and you know exactly when they're going to grow. You get just a lot of a weight to those mushrooms, and it's really nice. So why put in all this extra effort to you know, grow mushrooms outside? Like, that's kind of crazy, because it is a lot of effort to be inoculating all those logs. It's a lot of weight to be dragging around, to be stacking them up, putting them in the water. So why go through all that effort when you can just grow them inside and you get lots of mushrooms that way? Well, the reason why we do that is because mushrooms are really, really well known for having a very intricate chemistry, a very intricate immune system. They have a lot of different biochemicals that they'll create to protect themselves from things like viruses, bacteria, parasites, things like that. And mushrooms are actually very closely related to humans, even more so closely related to than they are to plants or to a lot of other organisms. So because, you know, we're kind of dealing with the same struggles, there are a lot of viruses, bacteria, all those things that attack us too, we can kind of use these chemicals that the mushrooms are producing for themselves for us, to help us. So like, think about like penicillin. That's a fungus. That's a fungus that we use to treat viruses. It's the same idea. So when you grow mushrooms inside, everything is done perfectly. They are very happy mushrooms. Everything that they could ever want is there. All the perfect humidity. They're not stressed at all. So the mycelium isn't going to put this effort into creating all of these biochemicals, all this chemistry, because they have nothing to worry about. But when you grow them outside, they're exposed to crazy temperatures changing, they're exposed to things trying to eat them, they're exposed to all of the elements outside, and so they're going to want to protect themselves. So they're going to ramp up those biochemicals that are active to protect themselves, and then we can then get in there and use that for ourselves. One of those main compounds that they create are known as glucans. It's a complex carbohydrate that is immunostimulating, immunomodulating, and so it's really good for our immune system because that's the main compound that they use for their own immune system. And it's also better for the land. When you're putting all of this effort into growing these mushrooms outside, you know, you're giving back to the land. These mushrooms are growing naturally as they would, and we also kind of use that practice to kind of pay attention to the things that are on the land. We're constantly planting more trees and more species on the land. And, you know, when you're working that closely, growing something outside, you're going to be paying more attention to what that land wants. So it's worth the effort. Which then brings us to our third topic, which is mushrooms as medicine, which is, I think, the most fascinating thing. So obviously these organisms are extremely important in the environment. They're extremely important to plants and all life surviving on this world. So, you know, what can we kind of take from that? I first like to tell people about the fact that, you know, there is this huge idea of mycophobia, especially in places like the US. And so what that word means is that, you know, we're kind of raised to kind of have this fear of mushrooms. You know, there are mushrooms out there that can really hurt you. There are mushrooms out there that you can get sick from if you were to eat them. But, you know, I kind of like to say it as, you know, there's also a lot of plants out there that can hurt you and a lot of animals out there that can hurt you too. We're just kind of raised with that fear of mushrooms for some reason. I remember like years back even bringing some people out foraging for the first time, and they were even fearful of touching the mushrooms because they thought that you weren't even supposed to do that. They really just freaked out to even like get near them. But I also kind of like like to give a plug that, there's not a single mushroom out there where if you touch it, even if you put it in your mouth, it can harm you. It always has to be ingested for if there was a poisonous mushroom to affect you. I like to give the example that there's a bolete out there, which is a common edible mushroom that has an almost identical twin that's a different species. And one mushroom is really, really yummy to eat and really good for you. The other one can get you sick if you were to eat it. The only difference really between the two from the naked eye is that the one that's edible kind of has a spicy taste to it, and the other one has no taste to it. And so you could actually, if you were unsure and found a bolete, you could put it in your mouth and kind of see if it has that spicy taste to it. If it does, then like, awesome, lucky day for you, got a mushroom to eat. And if it doesn't, it's not the good one, you could just spit it out and it won't harm you at all. But we're kind of now just starting to, especially here in like America, in the West, to kind of get over that. People are starting to realize how awesome how awesome this group is, how awesome the fungi community is, all the amazing things that are within them. So there is a huge difference between Eastern and Western medicine that kind of perpetuates a lot of that difference. In Eastern medicine, there's a lot more focus on preventive health. Kind of more focus on helping to keep your body actively healthy on a daily basis, as opposed to here in the West, it's kind of more wait till you get sick, and then once you're sick, you go to the doctor and they help treat those problems. Both are really good and very useful to humans, but we're really kind of lacking that focus on, paying attention to your body and keeping yourself healthy every day. And so in Eastern medicines, mushrooms have been utilized for a long time, for thousands of years. They're known as what we call adaptogenic medicine. And so what that means is they're not really targeting one specific part of your body really intensely to solve a problem. They actually kind of work with your body to help keep your body regulated, to help keep parts of you healthy. So you take it every single day. A lot of people use teas or tonics. So you're getting these mushrooms every single day to kind of keep you healthy. And so people have known that mushrooms have medicinal qualities for thousands of years. We didn't really need to prove that, but now in America, in the West, where all of these research institutions, these medical universities are starting to do research into mushrooms. And they're kind of confirming what, a lot of cultures already knew, and that, well, of course they're medicinal for you, because they have all of this, these crazy chemistries, this crazy bioactive compounds that, a lot of them maybe like the medical community has been trying to reproduce themselves, without knowing that it's out there in nature already. And so we kind of have this like new perspective, this new lens to kind of look at mushrooms through this scientific medical research. And so at Hawk Meadow, a lot of our medicinal mushrooms we put into what we call tinctures. And so for those of you who don't know, that's a very, very concentrated liquid where we'll take those mushrooms that we grow or wildcraft. They're put in alcohol for about a month. That'll pull out some of those bioactive compounds, start to help break it down. And then after that month, they'll go into water, and the water will get boiled all day for about 6 hours. So it's down to a very viscous liquid, because some of those compounds come out in that alcohol, and some need that heat to also break down and come out. And so those two liquids are put together. So what you're left with is this really concentrated liquid that then all you need is a couple drops a day to get those really amazing properties out of the mushrooms. Now, I always like to tell people, to go out and do your own research on all of this. I can talk all day about all the amazing medicinal properties of all of these mushrooms. But I think with anything, it's important just to kind of see what's out there for yourself too, just to kind of, do your own research, see what other people have been saying. You obviously know your body a lot more than anyone else can tell you. I think it's just a good practice just to look for yourself with anything. But let's meet some of those mushrooms that we're growing here and what they can do for you. So lion's mane, this is a super gorgeous mushroom. It grows on beech trees. It doesn't look like a lot of mushrooms that a lot of people are familiar with. They kind of grow in these big puffball shapes, and they're like kind of squishy, really cool texture, and they have these teeth. So unlike gills, they have these big prongs that come down. Those are holding all of the spores. But this mushroom is making huge waves in the medical community right now. All of this amazing research is coming out about what they can do for our cognitive functions, for our brain functions. So taking lion's mane is really good for your memory, things like focus and your reflexes. They're starting to do a lot of tests now for it to be used in Alzheimer's medications, dementia medications. It's also one of the only things that we found that can regrow the myelin sheath around damaged nerve cells. So it can become really important for people with MS who have those damaged cells to regrow them. It's really amazing. The capabilities of this mushroom are incredible. Another really gorgeous one is known as chaga. Chaga grows on birch trees, especially up in northern parts of the world where it's really, really cold. And they also don't really look like any kind of mushroom at all. They almost look like burnt pieces of wood coming out of the birch trees. It's actually not even technically a mushroom or fruiting body. It's known as a sclerotia, which is like a highly, highly packed kind of conglomerate of that mycelium growing out of the tree. But like, if you were to be walking around and see this, you would have no idea, there's anything even good for you or that it's even anything at all. But it's actually one of the oldest natural medicines that we know of. It's a really amazing ancient folk medicine. They even found it, I don't know if you guys remember, there was a body that was found in Italy, in Uzi, and he was dated to be 3400 BC, and he had a little satchel on him, and in that satchel they actually found remnants of this fungus, which is really cool. So it's been used for a long time, and so birch trees are already kind of innately medicinal. The sap within birch trees is antimicrobial, antibacterial. And so chaga kind of takes those qualities and puts it into one dense spot. They have huge amounts of antioxidants, more than any other food that we know of. So more than any berry, more than any food that we already know to be highly antioxidant filled. They could actively fight infections within your body by activating those white blood cells. And like a lot of these mushrooms, they're just really good for that overall balance in your body for your immune system. Another really amazing one is known as turkey tail. Turkey tail is unique in that it was the first mushroom that the FDA started to do research on. They did a huge study over many years looking at the capabilities of turkey tail as a medicine. And what they found was that it actually can work really well synergistically with patients who are going through chemotherapy. Turkey tail innately is anti-cancer. When taken every day, it could help keep your body cancer-free, but it works especially well for these patients going through these treatments to actively stop those cells from regrowing after treatments. They're also really good at alleviating pain, and so those patients going through those treatments can kind of help with the pain as well. And when taken every day, they're also really good for increasing your energy, your stamina, just overall feeling, ready to take on the day. But they're these really beautiful mushrooms. This picture right here are the ones that we're growing here on the farm. They're kind of this like blackish color, but if you were to see them out in the wild, there are some that just get these beautiful, beautiful colors, almost like rainbows of colors. Really, really pretty. Reishi is another really amazing mushroom. All of these are amazing. They are really important in Chinese and Japanese medicine. They're known as the mushroom of immortality or queen mushroom, just because they kind of have this huge range of things that they help in your body. They're extremely anti-inflammatory. They're really good for regulating your respiratory system. So I've heard amazing things from people with allergies or asthma symptoms when they start taking this reishi, that they see those symptoms just completely go away, which is really, really cool. They're really gorgeous, these beautiful like reddish and yellow fruiting bodies. They'll only grow on hemlocks here in the US, but when you see them, like, you can't miss them. They're just so beautiful. They're also really good for your heart health, also anti-cancer, and they're also really good for your nervous system. and shiitake too, which is one that we really have only thought of here in the US as a mushroom that you eat, that you would serve on a plate at dinner time. They're also a really good medicine. They even say a shiitake a day keeps the doctor away. It's kind of silly. They're really good at lowering that. They're really good for people with high blood pressure, lowering that blood pressure. They're immunostimulating, and they've actually been shown positively to help people with HIV. Kind of fight infection in their body. And there was also a really cool study that was done on one of the active ingredients in shiitake, where a pharmaceutical company came in and they took what they thought was the active ingredient in shiitake, lecithin, and they kind of isolated it into its own, so it's away from the mushroom. They gave some groups of patients this isolated compound, and then they gave others kind of like a tea or a tincture that had the entire mushroom together. And what they found was the patient that had the whole mushrooms actually showed a lot more positive in lowering that high blood pressure than other patients, because, you know, like I said before, mushrooms have a really, really complex chemistry that we barely understand yet. And so, you know, we can think that one compound in that mushroom is a thing that's medicinal, but really we're finding that it has to work all together synergistically with the whole mushroom, which is a big part of herbalism in general, is kind of focusing on using like the whole of a plant or the whole of a mushroom, as opposed to, you know, what a lot of medical research groups are doing now, which is kind of trying to isolate that one compound. So what is the future of mycology? Ethnomycology, that refers to the study of mycology and how it relates to humans. This is a new understanding. We're learning new things about mushrooms every single day. And, you know, just kind of the worlds that's opening up for us is really, really amazing. You know, mushrooms, like I said, are at the forefront of nutrient cycling, of breaking complex things down into organic materials. So they're actually starting to be used in remediation projects. So where there may have been heavy metals dumped or soil that's unhealthy, especially for places that have big farms with cows and there's runoff and they don't want going into the water system, they'll put mushrooms in that soil, put that mycelium in the soil, and that mycelium can start breaking down those materials that are bad in the soil to kind of leave us with organic materials that's healthy and good for the soil. They've even been doing studies in places like Chernobyl with them breaking down radioactive waste. There's also a lot of work being done with things like compostable packaging, so making like molds with that mycelium to grow into. And so it's a really, really dense, really strong packaging, but at the end of the day, you could kind of throw it aside and it'll break down back into the earth. And like I said, it's also just really good at improving that soil health. So a lot of people are starting to use it for environmental justice projects. But then I also think it's important to also just think about, you know, it's not just about what we're taking from these mushrooms. I think they could also be something that we learn a lot from, just in, you know, like how we can change as humans, how we can, you know, mushrooms, their entire lifestyle is built off of kind of, you know, supporting communities and doing a lot of like give and take with organisms around them, kind of like a lot of like mutual aid that people are seeing today in response to COVID. Like that's what mushrooms have been doing there for thousands and thousands of years. So it's important to think about like, well, what can we learn from them? Okay, so that's what I have for you there. If you are interested in checking out any of our tinctures, this is our website right here, hawkmeadowfarm.com. Right now, for this next week, we're going to have a coupon code for 15% off any of our tinctures if you use the code Mueller. Anyone who's local to upstate New York area, there's going to be a farm trail weekend this upcoming weekend, kind of like an open house for a bunch of farms around. That's going to be this Saturday, the 26th. We'll be open from 10 to 5 for people to just come in as they please, see our property. We'll be talking about mushrooms, showing off our new building. If you can't make it that weekend, we're also always welcoming people to come check us out through tours. And that's what I got for you guys on that end. Let me get out of this. Okay.
Thank you so much, Emma. That was awesome. We do have some Q&A on the right-hand part of your screen. So if you do see that, how often can you force a log in a growing season? There's just a couple of questions there. So we can take a little bit of time to Do you see it? I can just read it to you actually if you want.
Oh, actually, here it is.
Yeah.
Okay. See if I can get it to expand because I can't really see questions. Should you be able to just read this?
Yeah, I'll read them. I'll read them to you.
Yeah.
So the first question is, how often can you force a log in a growing season?
Great. I talk about. I'm sorry, I was kind of rushing through that part. You could actually force a log twice within a growing season. And so twice a year over 4 or 5 years, you're gonna get a lot of mushrooms from those logs. And they need about 10 weeks in between forcings in order to kind of rest and get their bearings again.
Okay, the next question is, how feasible is it for the hobbyist to be able to grow sufficient quantities of mycorrhizal? I don't know if I said that correctly.
Can you say that one more time?
Oh, there's way more to the question. Hold on. How feasible is it for the hobbyist to be able to grow sufficient quantities of mycorrhizal mushrooms to add to poor soils or mulch, or perhaps do it as a small business? What species is a good general species that can convert many types of soil?
Well, really good species for doing specifically microremediation stuff would be oyster mushrooms. They're used a lot with a lot of these microremediation projects right now, and they're also general. They're also very easy to grow, kind of willing to grow in different circumstances while breaking down a lot of those soil. And it's a very feasible thing. So we'll actually sell inoculated logs at the farm just for like maybe a family wants a couple like logs of mushrooms. And so it's really easy to do as long as you have some water, or you could also just do passive growing. Just let them grow, but it's very feasible. It's very affordable. You can buy that spawn online through a lot of different companies pretty easily. And then all you would need is wood or pine shavings if you're going to do mycorrhizal, whatever species you were going to use.
Okay. Are these tinctures rigorously evaluated for medicinal effects before being sold, or are the claims just based on folk medicine, anecdote, and studies on the whole mushroom? How is the recommended dosage evaluated?
So that's a great question. So that's like I like to say for people to do their own research. So things like tinctures and teas and tonics of these mushrooms, they have been used for thousands of years in Eastern medicine. But it's really only been, like I said, relatively recently when the science community, the medical community here in the West have been starting to rigorously test them. And so there's a lot of research out there. There aren't many that are like confirmed through things like the FDA yet, but you can go and do your own research and see what these scientists, what this medical community is saying about them. And for like our tinctures, it's usually like a dropper full, so like 10 to 20 drops of mushrooms a day of that tincture is what we say. But like I said, we like everyone to do their own research too.
There are so many questions coming in.
Yeah.
Okay. Okay. Do you keep growing mushrooms through the winter?
No, so mushrooms need it. They need the ground to at least be thawed. So like I said, it's kind of within 55 degrees is when they'll start growing. There's different mushrooms so like within shiitake, there's different strains of mushrooms with different strains of shiitake. So it's kind of like the same thing as apples. There's all different kinds of apples. There's different types of shiitake. And there are some that prefer to grow in the colder weather, known as our cold weather shiitake, or within like those in-between seasons, like the fall and the spring. But even still, they won't grow in the dead of winter. They need moisture in the air, they need water to be flowing, and they need the ground to be thawed. And so it's usually like really in the beginning of spring, right when that snow melts is when they'll start growing. And then we'll be producing mushrooms on our farm until about the end of October. But in the winter time, that mycelium is kind of almost going to go into like a hibernation to kind of like relax in that time and not put all of its energy into fruiting bodies.
Okay, I'm just gonna choose a couple of more. I'm sorry for the ones that we won't get to.
That's it.
Unless you want to just keep going, you can tell me when you're done.
Oh, that's fine.
Let's keep going. Okay. Okay, this one's cool. What are your thoughts on mycelium as a structural material? And then there's also, what do you think about the mycelium-based coffins that people are working on? Have you heard?
Both of those are super, super cool. So for those of you who don't know about the coffins, I've seen coffins, and I've also seen people make suits made out of this mycelium. So it's, the same idea as, the mushrooms are, the mycelium, whole purpose is to break down materials and give those organic materials back to the soil. And so, when we die, that's a lot of organic material that is not going to go back into the soil because, we're put in coffins or wherever people are buried. And so there are all these companies now that are trying to figure out ways that we could kind of, use mycelium to help break down even humans after we pass. I think that's really, really cool. I think it would be a lot less waste going into the earth. And it's kind of like, I've always kind of seen it as like humbling in a way that, we can get so much, whether it's food or medicine or even just joy out of mushrooms during our lifetime. And then at the end of our lives, just to kind of have this organism that we've gotten so much from kind of like help give us back to the land too. And same with buildings. Mycelium can be really, really strong when it's grown really tightly, really compactly. And so it makes great building materials. And there are some companies that are doing amazing things with that.
Sign me up for a mycelium coffin. Let's see. Okay, so what kind of mushroom grows on oil spilled soil in this area?
A lot of people use those oyster mushrooms that I talked about. Also, wine cap mushrooms will be grown that way. But there's so many species of mushrooms that can help break those things down, and we're only just kind of scratching the surface now on which species can do that. But the things that we're finding that fungi can break down is like incredible. They're even finding some mushrooms capable of breaking down like microplastics in water, which is really crazy.
Okay. All right. I'm trying to grow some oyster mushrooms on a coffee substrate. This is my first ever try. I have lots of lovely white mycelium, but also a little tiny spot that looks a little blue. Is that mold? Are my mycelium doomed?
If it's mold, they're not necessarily doomed because, like I said, mushrooms are really good at having really strong immune systems for fighting competition off. So I would just keep an eye on it. But I think that if it's just a little bit of mold, that mycelium is really going to be easy for it to kind of outcompete that mold really quickly.
When and where to forage for morels? Is there a conservation concern from over-foraging?
That's a really interesting question about conservation. So morels are early spring mushrooms. They're one of the first mushrooms that you'll see. It's a very, very tiny window, though. They'll only grow for about 2 or 3 weeks. And so it's usually like right in the beginning of the spring, and they'll start growing. And there is some talk of like what they kind of like. Some people say they like hickory trees, or they like, certain types of plants around them, which could all be true. But in my experience with morels, they kind of like to show themselves wherever they kind of feel like growing. I've never even found them where people say that they're often found. I'll usually find them in like the most random ecosystems around. And for some mushrooms, like a lot of old growth forest mushrooms, there is a little bit of concern with over harvesting, but it's not like a plant where, if you harvest it, you're taking the entire organism out. It's not going to grow back. That's just the fruiting body. And so the organism underneath, that mycelium in the ground, is still going to be fine. It's still going to keep growing. It's still going to reproduce. But a lot of people say you only, it's always just a good idea to never take more than half of what you see in an ecosystem, just to ensure that there's still some reproducing with anything, whether that be plants or mushrooms. And a lot of people won't pick certain mushrooms until after the spores of that mushroom have dropped, just to ensure that it'll still reproduce.
Okay, are you good with 2 more?
Yeah, let's do it.
Okay. Let me get back to it 1 sec. Oh, why do mushrooms need to be mixed with alcohol in tinctures?
Alcohol is just a really common liquid that we use to extract those compounds, to break down those compounds that we need. You don't always have to use alcohol. Some people will use things like vinegar for tinctures to pull out those substances. Alcohol just works a lot better at breaking down those substances and pulling them out of the mushroom. And we do need water too. There's some compounds that are water soluble only. They won't break down in that alcohol, which is why we do that. We call double extraction. So we'll do the alcohol and we'll do the boiling water to get those out. So it kind of needs both, especially with mushrooms.
Okay, I'm gonna take 1 more. Are shiitakes grown on maple logs as tasty as those grown on oaks?
Good question. I personally can't really tell the difference as well as some people can with what kind of trees they've grown. The thing that I've heard is, I think it's hickory trees. Those shiitake will be a little bit more spicy than other shiitake. But they're all going to have like slightly different qualities based on that wood, but I personally can't really tell.
Okay. I think I covered most of the questions. I'm sorry if I didn't get to your questions, but I just want to say thank you again, Emma. I do have the shiitake mushroom tincture. I actually wound up spending $80 on mushroom tincture after leaving the farm, and I love them. So thank you, and stay tuned for more Speaking of Nature talks. Just go on our Facebook or Instagram for those announcements. Thank you, everyone. Thank you, Emma.
Thank you so much. Thank you for having me.
Have a good night.